Okay, example 4. Find the volume of the solid bounded by z equal x squared, z equals 0. So we know how that works. It's running from the ground up to z equal x squared. Now, I'm looking at the domain z equal x and 2, 2. And I added x equals 0 just to make sure that we're talking about this region. So, if I want the volume, the double integral over region D, there's D, of the top minus the bottom. And I'm going to run the x first. X is going to run from 0. Where does y equal x? So 2x equal 2, x equal 1. From 0 to 1. And y runs from y equal x to y terminates at 2 minus x. And that would be that actual volume. Now we get to the next problem, and would like to find the volume bounded by let's see, a sphere z equals 0 in the first octant. So a sphere would be 1, 2, 3, 1, 2, 3, 1, 2, 3. So a quarter of it, like a quarter of an orange. And if I cut this by y equal x, and x equals 0, so we're talking about this region. This is region D. That part. Now, volume would be the double integral over region D of the top minus the bottom, the square root of 9 minus x squared minus y squared minus 0, dA. That would be the square root of 9 minus x squared minus y squared. And if I look at what that d look like, it looks like y equal x. You go up to 3, and that's circular. There's that part. Now, I could figure out what the intercepts are. I could say let y run from, x run from 0, and on the floor this is really x squared plus y squared equal 9. But if y equal x, to figure out where that point happens, I could replace y by x. So I'll get 2x squared equal 9, x equal plus or minus 3 over radical 2. So this is 3 over radical 2. And then y would run from the line and it would terminate on y equal the square root of 9 minus x squared. There. That would be one way of doing the problem. Now once we learn about polar, there'll be a much easier way of doing that. That's our next section. Next problem. Sketch the graph of the solid so we're looking at y running between 0, y equals 0, and 4 minus y equal 4 minus x squared is a graph that looks like this. So 1, 2, 3, 4, except we're cutting x to run between 0 and 2. So we're looking really at this portion. This should be running up. It's a prism, but I'm cutting that off by z equal 2. So if this is 2, that's 0. Okay, I see. So this is gonna be cut by a knife coming down at this angle. Well, it's gonna cut through and it's gonna look something like this, where this is z equal 2 minus x. This side right here would be y equal 4 minus x squared, and x runs between 0 and 2. That would be the region right there. And that would be it for this section.